Alright folks, this is Euclid Book 6, proposition number 2. And it says, if a straight line be drawn parallel to one of the sides of a triangle, it will cut the sides of the triangle proportionally. And if the sides of the triangle be cut proportionally, the line joining the points of section will be parallel to the remaining side of the triangle. In other words, there's two things we're going to try to prove here. Alright, we're going to draw DE parallel to BC. Well, let's first find out what we got here. We've got a triangle. It has A, B, and C. We're going to draw a line. It's called DE, and DE is going to be parallel to BC. So far, so good. Don't you just love it when you get the given parts of these proofs? Alright. For let DE be parallel to BC, one of the sides of the triangle ABC, well, obviously, BC is one of the three sides of the triangle ABC. So far, so good. And then the first thing we're going to do is prove that BD is to DA. Well, what's BD? We're going to prove that BD is to DA as CE is to EA. CE is to EA. In other words, we're going to have a proportion here. As this, let's just say this is going to be a proportion. Now, you remember all those ratios we talked about in Book 5. As 1 is to 2, so as 1 is to 2. Okay, that's the kind of thing we're trying to get here. Okay, for let BE and CD be joined. Well, where's BE? Well, this is BE, and this is CD. We're going to join these two lines. Actually, when they're saying join them, we mean draw a line from B to E and draw a line from C to D. That's what it means. Therefore, the triangle BDE is equal to the triangle CDE. So what we're saying here is that triangle BDE has the same area as, let's see, CDE. Okay? BDE, there's the area right there. CDE is the same area, so this area is equal to that area. So far, so good. Alright. The reason why they have the same area is they are on the same base DE and in the same parallels DE and BC. Okay? They are on the same base DE, and they are in the same parallels DE and BC. And this is by Euclid Book 1, proposition number 38. And the triangle ADE is another area. ADE, ADE. This is another area. But equals have the same ratio to the same, which is by Euclid Book 5, proposition number 7. Therefore, as the triangle BDE is to the triangle ADE, okay, BDE as to ADE, so as this area is to this area, so the triangle CDE is to the triangle ADE. So, basically what he's saying is that as the area of BDE, which is this triangle right here, is to ADE, so the area of CDE, which is this area right here, is to the ADE. As 1 is to 2, as 1 is to 2. So far, again, so good. But as the triangle BDE is to ADE, so is BD to DA. So what he's saying here is, as this area here is to this area, so this line BD is to DA. As 1 is to 2, so as 1 is to 2. Okay, I'll say that again. BDE is an area. It's a triangular area. ADE is a triangular area. So as 1, so we're saying the area this is 1, the area this is 2. We're now going to say the length of BD is 1 and the length of DA is 2. So as one area is to the next area, so as one line is to the next line. For being under the same height, the perpendicular drawn from E to AB. Well, what's the perpendicular from? Well, from E, okay, from E to AD. Well, here's line AD, here is E, it is drawn from here to here. That's a perpendicular. For being under the same height, the perpendicular drawn from E to AB, they are to one another as their bases. This is by Euclid's Book 6, proposition number 1, which we just proved. For the same reason also as the triangle CDE is to ADE, well, let's go ahead again. CDE, CDE, that area right there, as to ADE, which is this, as 1 is to 2, so CE is to EA. CE is to EA. The length of CE would be 1, the length of EA would be 2. So as this area is to this area, so as this line is to this line. Again, that's a ratio. Therefore, also as BD is to DA, so as CE is to EA. So, as this line being 1, this line being 2, this line being 1, this line being 2, this is to this as this is to that. BD is to DA as CE is to EA. Same ratio. Alright, we've proved part of this. Now let's go on with the rest of the proof. Again, let the sides AB, AC of the triangle ABC be cut proportionally. So as BD is to DA, BD is to DA, so CE is to EA. Again, CE is to EA. These have been cut proportionally. As 1 is to 2, as 1 is to 2. And let DE be joined. So, first we're going to plot points D and E, so that BD is to DA as CE is to EA. When we draw that line, I say DE is parallel to BC. So what Euclid's saying is that because we've plotted points D and E, which cut these two lines proportionally, then DE is then parallel to BC. Okay. For with the same construction, since BD is to DA, so as CE is to EA, we just already established that, BD is to DA as CE is to EA. But as BD is to DA, so is triangle BDE is to triangle ADE. BDE, ADE, so this area is 1 is to 2. And as CE is to EA, so the triangle CDE is to the triangle ADE. And all this is proven by Euclid Book 6, proposition number 1. Alright, so we're saying here, CE is to EA, so therefore the area of CDE is to the area of EDA. This area is 1, this area is 2. Just like this line is 1, CE is 1, and EA is 2. So as 1 is to 2, so as this one area is to 2 area. As the triangle BDE is to the triangle ADE, so is the triangle CDE to the triangle ADE. We've just established that the area of BDE is in proportion to ADE, and we just established the CDE is also in proportion to ADE. And this is by Euclid Book 5, proposition number 2. I think it's 2. Maybe 11, I'm sorry. Whether it's 2 or, well, it's 2. Euclid Book 5, proposition number 2. Therefore, each of the triangles BDE, CDE have the same ratio to ADE. Therefore, the triangle BDE is equal to the triangle CDE by Euclid Book 5, proposition number 9. And they are on the same base DE. So, BDE, CDE, these two triangles here have the same area. And since they're on the same base DE, but equal triangles which are on the same base are also on the same parallels by Euclid Book 1, proposition number 39. Therefore, DE is parallel to BC. And we just established that DE is parallel to BC. And that's the proof. Alright, I will tell you more in a future video, so stay tuned.